Dear students, in this class we will discuss a few more points about the notion of utility which is behind the preferences of the consumers. Classical economists believed that utility is an indicator of the overall well-being of a person. They also believed that utility is a numeric measure of a person's happiness. That means utility is measurable. And it is natural to assume that a consumer will make a choice. His choice of a consumption bundle is to maximize utility, or utility is the basis of choice. Utility is the basis of choice. If utility is measurable, and if you can associate a particular numerical value to each bundle, then we can easily say which bundle a consumer will choose. He will choose the bundle which has the largest utility value. But classical economists were silent about the question how to quantify the amount of utility associated with the different choices. Is one person's utility same as another person's utility? If I say that I will get 10 utility from a bundle, another person says that he will get 20 utils from a bundle, how to compare the number 10 and 20? And a second issue is, what would it mean by saying that an extra chocolate give twice utility as an extra carrot? If you consume X, you will get a twice utility. You will get Y, you will get a twice utility. What is meant by this? So, utility is something which is psychological, cannot be measured. We have problems associated with quantifying utility, as it is a mental phenomena. Comparison is not possible, etc., etc. So, due to these problems, economists abandoned old-fashioned view of utility as a measure of happiness. Instead, the theory of consumer behavior has been reformulated entirely in terms of consumer preferences. The theory of consumer behavior has been reformulated in terms of what is known as consumer preferences. And utility is only a way of describing preferences. The theory of consumer behavior, which was originally specified in terms of utility, has been reformulated in terms of preferences. And utility is only a way of describing preferences. That is, originally, preferences were defined in terms of utility. For example, if you have a bundle x1, y1, another bundle x2, y2, x1, y1 and another bundle x2, y2, and if x1, y1 is preferred to x2, y2, it means that this bundle will give more utility. That is the old-fashioned view. But now we think the other way. That is, the preference of the consumer are fundamental description for analyzing choice. If two bundles are available And if the consumer prefers the bundle x1 y1 over x2 y2, then we will give a utility value which is higher for x1 y1 than x2 y2. So preferences are used to describe choices, and utility is only a way to describe preferences. Also, all that mattered about utility as far as choice behavior is concerned is whether X bundle has a utility, whether this bundle has a utility which is higher than this. So the magnitude is not important. Suppose utility from this may be 10, this is 5, or it may be 100, or it may be 2, or it may be thousands, it may be 0.5. As far as preferences are concerned, utility simply means whether you will get more utility from one from the other. The size relation is not important. So preference is the basis of choice, utility is not the basis of choice. Now a utility function, as we have defined earlier, is a way of assigning a number to every consumption bundle. Utility function is a way of assigning numbers to every bundle like 10, 5, 2, etc. such that more preferred bundles will get larger number than less preferred bundles. More preferred bundles will get a larger number than less preferred bundle. The bundle x1 y1 is preferred to x2 y2 if and only if u x1 y1 is greater than u x2 y2. So utility function is a way of assigning numbers to every bundle such that more preferred bundles will get a larger utility number than less preferred. And the only property of the utility assignment that is important is how it orders, ranks bundles. The size of utility difference doesn't matter. As far as utility function is concerned, when you assign utility numbers, more preferred bundles will get a large number than less preferred bundles. The size difference is not important. And this conceptualization of utility is known as ordinal utility. Ordinal utility. Utility is not cardinal, utility is ordinal. Utility is used to order, rank bundles as first, second, third, etc., etc. So since only ranking matters, there can be no unique way to assign utilities to bundles. There is no unique way to assign numbers such as 10, 5, 2, etc. This may be 10 and 5 or 102 or 1000 and 0.5 like that. If we can find one way to assign utility numbers, then we have infinite number of ways to do it. One way, infinite number of ways to assign utility numbers. So if u x1 y1, if u x1 y1 represents a way to assign utility numbers to x1 y1, then multiplying u x1 y1 with the number 2 or any other positive number is as good as a way to assign utilities. And multiplying this with 2 is an example of what is known as monotonic transformation. Monotonic transformation. Monotonic transformation. And monotonic transformation is a way of transforming one set of numbers into another set in a way which preserves the order of numbers. That is, we transform one set of numbers into another set of numbers in such a way that the order is preserved. And we typically represent a monotonic transformation by a function fu that transform each number u into some other number fu that preserve the order of the number, in the sense that if u1 is greater than u2, f of u1 is greater than f of u2. That is the transformation of u1 and u2 into f of u1, u2. Preserving the order of numbers is an example of monotonic transformation. And we have discussed earlier, multiplying by 3 or adding a number 17, raising to the power 3. All these are examples of monotonic transformation. And fu is, if monotonic transformation is differentiable, then we will say that the condition for monotonic transformation is f dash u is greater than 0. F dash u is greater than 0. So to summarize, a monotonic transformation of a utility function is a utility function that represents the same preferences as the original utility function. Geometrically, a utility function is a way to label indifference curves. Higher indifference curves getting assigned large numbers. So geometrically, utility numbers are represented by indifference curves, and higher indifference curves will get higher utility numbers. So when you study the theory of consumer behavior using indifference curves, remember this: from preferences to choice, assumptions about preferences, and the concept of ordinal utility, monotonic transformation, all these points, concepts will be kept in mind.